Alrighty, next up, problem number 2. So once again, we have a single rational expression with a 0, so we don't have to do any common denominator stuff, which is nice. But we do need to go through and factor everything so that we can do this problem. So that's going to be the second thing we do. What do we need to do first? We need to identify, do we want positives or negatives for this particular inequality, okay? So remember, think of this is your function. And this time we have a less than 0. So what kinds of numbers are going to give us this is less than 0? We want negatives. So when we get to the testing stage, we want to make sure that we're finding what makes negative values come out of this expression, okay? So now we need to go through, we need to factor it first so that we can identify, well, what are our domain restrictions with our open circles, and what are our x-intercepts or numerator equal to 0, okay? All right, so factoring fun. Let's see. Let's get creative here. 3 times negative 10 is negative 30. Factors of negative 30 that add up to 1 would be a 6 and a 5. But to get there, to get a 3x squared, I need a 3x and an x. I need to end up with a 6 and a 5, so if I do 3 times 2, I'll get a 6 out of this. And then if I put a 5 here, I'll get a 5. Positive 6, negative 5. And then just double check, FOIL it out, make sure that your factoring makes sense. Okay? But this is in fact how this one's going to factor. The denominator has a GCF involved, so I can make that 2 times x plus 3. Keep in mind this is still less than 0. All right, so I'm going to shorthand things a little bit here. Domain restrictions, DR for domain restrictions. That's going to come from the denominator equal to 0. There's no variable in this part right here, so that doesn't factor in at all. But this is going to be x equals negative 3. So that's going to be an open circle there, because domain restrictions are always open circles. And then if we take a look at the numerator, sorry if I'm in the way here. All right, if we want to look at the numerator now equal to 0, we're going to get x equals 5/3. And we're also going to get negative 2. Now, will those be open circles or closed circles? And that's based on the symbol itself. If there's no equal to, it's open circles. If there is an equal to, it's closed. So no equal to means open. So the good news is everything's open here, so it's all open circles and all parentheses, okay? So that's the beginning part. Numerator equal to 0, denominator equal to 0. Get those numbers. Now we're ready to start our number line. So this time I have 3 values that I need on here, and they need to go in order. So I have negative 3, negative 2, and 5/3, okay? I don't care if the spacing is equal or not. It doesn't need to be a proper number line. They just need to be order from least to greatest. Otherwise, things aren't going to quite work out. We said that everything was going to be open circles, so I'm going to draw in my 3 open circles above them. So now that I have 3 values, that creates 4 intervals to test. Okay, and this is where things get a little bit more involved. We just need to focus on, do we get positives or negatives, okay? So I'm going to start all the way over here on the left. I'm going to use x equals negative 4. All right, now you get to choose, do you want to plug it into the original and compute value over value? Or do you want to use the factored form and just focus on signs? So there's a nice little trick that you can use if you have the factored form. All right. So what I want you to do is think about, if I plug negative 4 into this factor, will it come out to a positive or negative? So 3 times negative 4 is negative 12. Negative 12 minus 5, that's a negative. Okay, so I've got a negative number to start off. Times. If I plug negative 4 into this expression, negative 4 plus 2, that's another negative number. So I've got 2 negatives in the numerator, divided by. Denominator, I have 2 times negative 4 plus 3, that's another negative number. So if I just go through and do a sign analysis here, the numerator is a positive, the denominator is a negative, a positive divided by a negative is a negative. This is going to be a negative over here. Do we want negatives or do we want positives? We said we wanted negatives, so we're going to keep that section. This is going to work in our inequality. Okay? So again, I'm plugging this number into the factors. I'm not computing the actual values and writing them down. I'm just writing, do I get positives or negatives? Okay? So we're doing a sign analysis instead of a numerical analysis. It's a little bit quicker. Okay. Now I'm going to try plugging in a number in here. So I'm going to do from -3 to -2. So I'm going to have to plug in a fraction or a decimal, okay, because there are no integers in between. So I'm going to plug in x equals -2.5. Okay. So I'm going to do that down here. It's going to get a little bit messy. I'm going to try to keep it organized for you guys. All right, so again, I'm plugging it into this factored form. So 3 times -2.5 minus another 5, that'll come out negative. Okay. If I plug in -2.5 plus 2, that'll be a negative. Divided by. Okay, so we've got two negatives up top. In the denominator, I have 2 times -2.5 plus 3 is a positive. So now I'm going to have a positive up top, a positive on the bottom. That comes out to a positive overall. So this would be positive values. We don't want positives, we want negatives, so that's not going to work. Oh, I forgot to write, this is for this right here, okay? All right, now we're gonna need to do 2 more similar tests, okay? Switch colors, see if that helps a little bit. So now I wanna pick something right in here between -2 and 1 2/3. So let's do x equals 0. So if I plug in x equals 0 here, well, that'll give me -5 times +2. So I'll get a negative times a positive divided by 2 times 0 plus 3 is a positive. So I have a negative up top, a positive on the bottom. That is a negative overall. This will be a negative. So I will want to keep that section right there. Okay? And now we need one more test. Now I need to test a value over here. I'm going to try, let's see, 5/3 is 1 2/3, so I'm going to plug in 2. That's a little bit bigger. All right, I'm going to do it down here. If I plug in x equals 2, let's see what happens. So 2 times 3 is 6. 6 minus 5 is a positive. 2 plus 2 is a positive. And then 2 times, 2 plus 3 is a positive. These are all positives. When you do a positive divided by a positive, you get a positive overall. So these are positives over here, which we do not want. So we have 2 intervals again for this particular one. All right? I'm going to give myself a little space over there to write the final answer. Runaway marker. Okay, so we've got an interval on the left. Starts at -∞, goes until -3. And these are all parentheses because they were all open circles. The next one goes from -2 up until 5/3. So this is the final solution to the inequality. Okay? All right, there you go.